All right, pre-calc 11, here we go. More trig, more sine law. It's something called the ambiguous case. It's another beautiful May day. Hope you're having a good one. Here we go. All right, sine law, which you've already done if you look at the previous lesson, except this is the ambiguous case, which is the one that I said was it is a real pain, and this is a real pun intended. It's a real pain in the angle side. So, because you're going to look for, it's going to have a side angle or angle side. Now textbooks, they won't print angle side because it looks like they're calling you a donkey, but they'll call it side angle. But it's the same thing. And it's 2 questions in the textbook, not a lot of questions, but you'll see how it has a little twist and you have to be on the ball to catch it. So I'm going to do 3 examples. The 3 things that will happen to you when you are dealing with sine law ambiguous case. So here's the first example. Is in triangle PQR, angle Q is 30 degrees, little q is 40 centimeters, little r is 24 centimeters, find angle R. Now, at the moment, I would have no idea if this was the ambiguous case. But as soon as I see an angle and 2 sides, it has 2 potentials. It's either going to be an angle where you have the contained angle and have the SAS from cosine law, or it's going to be the non-contained angle, which will be the unfortunate ambiguous case. So I would draw this. As soon as I see one angle and 2 sides, I always personally draw the angle, I don't know why, I draw it on the left side. So I'm going to make that my 30 degrees. I'm just drawing it without a ruler, just kind of a quick little sketch. Yeah, that could be 30 degrees. Side Q is going to be somewhere over here across from this side. And again, I'm just going to quickly sketch it. So here's my sketch. I don't know, I'm just making it up. So this little q here is 40 degree or 40 centimeters. And R, which could go either here or here, I prefer personally to put it up here. And I'll show you why that is later. So I can easily see with that data, the angle is not between. And it is angle side. As soon as I see that, I'm like ding, 2 things. Sine law, and be careful. This is called ambiguous because you'll see in a moment this can have more than meets the eye. And we'll go through the examples to show you what I mean by that. So, first thing is, well, sine law. I know the sine law formula. Sine of big A over little a equals sine of big B over little b. I'm looking for angle side pairs. There's one angle side pair. What do I want? I want big R, which is this. So that obviously would then make my next angle side pair. So I'm going to get sine of 30 degrees, because that's my one A and big A, so to speak. Big A and little a. Sine of 30 degrees over 40 centimeters is equal to sine of big R, which is my B in this case, over little b, which is little r here, 24. And at the moment, if I don't worry about this, I solve this as normal, but I'll show you where this gets a little bit sneaky. Solve this by cross multiplying. So 24 times sine 30 equals, or divided by 40 equals sine R. Go to my calculator, type this in, and you end up with 24 times sine 30 divided by 40. You end up with 0.3. That's a nice one where there's no lots of decimals, but that's just fluke. And then I will go second sine of 0.3. And out comes 17.5 rounded degrees. There's my angle R. That was second sine of 0.3. Okay, and at the moment, that's what you would have done in the last lesson. You're wondering, like, why is this any different? The reason this has potential issues is, if you think about the way this is initially drawn, like this, when this is 24, and the reason I draw it this way, this angle is fixed for sure, this length is fixed for sure, this length is fixed for sure. This angle, and this side are not fixed at the moment until we figure out the answer. The trouble is what can happen, it's almost like there's a hinge here. it's possible for this side sometimes to have been over here and drawn this way. But in this particular example, if this is 40 degree or 40 length and this is only 24, this is longer than this. So if I were to hinge this around, do you agree the 40 would always be sticking past? 40 would be too far, too far, too far, too far. It would even become too far over here. So I know this only has one answer because this 40 does not have the possibility of spinning around. Let's do the second example and show you where you do get into a situation. So this only has one solution. Okay, we'll show you an example where there is possibly two, and that's where you got to be careful because people just get one answer and they walk away not thinking. So here's the next example, which, if you look, I've just changed one thing. I've kept the angle Q the same, I've kept little r the same, but I've changed little q. And we'll show you how this has great impact on the question. So again, I'm going to draw a quick little picture of what I think I have. So this is 30 degrees, there's angle Q, little q is 20, and little r is 24. And again, I see it's sine law, it's ambiguous because it's angle side side. So I do the exact same thing. I do my setup with my sine law. Sine of 30 degrees divided by 20 equals sine of big R over 24. So there's my angle side pair, there's my angle side pair. Same thing, no different. You're looking at this going, McPhee, why is this any different? And I agree, it's not yet. And I get my one answer out, which in this case is 24 times sine 30 divided by 20. And I get 0.6. R is equal to whatever second sine of 0.6 is. Second sine 0.6. I'm just getting nice numbers because I picked 30 degrees. And I'm going to round that. Let's make it 36.9. 37 basically, but 36.9 degrees is angle R. And I'm all excited because I have the answer. But here's where there is a little twist to this. If you look here, that looks like it could easily have been 37 degrees. It makes sense. Here's where it gets sneaky. This was my case 1 answer. If you think of a little hinge here, this 20 centimeters is less than 24. This could have been, and watch carefully, there's the same 24 centimeters for R. There's the same 30 degrees. This 20 centimeter length could have rotated over to here, and it could have been drawn like this. And look at that very carefully. That's the same Q, the same little r, the same little q, with a completely different shaped triangle, with a completely different size of angle r. And that meets the same question. So it's like, uh-oh, I have a case 2. If someone told me, draw a triangle with those dimensions, I would have had to say to them, well, there's 2 potential cases. Which one do you want, or do you want both? So one answer out will come out. If we look at the first example we did, the reason we didn't have to go to case 2 is because this length here was too big to rotate around. It would always extended past the 24. So right there, and I know by logic there is no second case. Here, this is smaller than that, so there is potential for a second answer. So the question is, how do I find it? And the key is in this little picture here. If you look here, do you agree this is 20? When I rotate it over to here, this is also 20. This is an isosceles triangle here that I've kind of created. If these two sides are the same, this angle and this angle are the same. So I know this little backside angle here is 37 or 36.9 degrees. I then know in this little picture here, this first answer out is the backside angle here. And I'm one step away from case 2 answer. So the case 2 answer if you look here, makes sense. This full line here is 180, 180 degrees on a line, minus this original case 1 answer. That will be, so if I subtract from 180, I get 143.1 degrees. So let's draw both situations that we came up with there, because this is easy to miss. So here's case 1 picture. Case 1 picture looked like this. 30 degrees, 24, 20. This here is 36.9 degrees. That's case 1. Case 2 looked like this. 30 degrees, 24, 20. That angle there, though, is 143.1. Alrighty, hopefully that makes sense. Now, let's say you had a bad day and you did this for the first example and you didn't see that this was too long and you went, oh, I'm just going to do what McPhee said. I'm going to do the 180 rule. My first answer out was 17.5. Oh, the other one, not thinking, would be the 180 rule, 180 minus 17.5. And you might have done that, not thinking, or thinking, one of the two. And you end up with, oops, 0.5. You end up with 162.5 degrees. Now the reason that doesn't work, think about if you put 162.5 in for R and you already have a 30 in the triangle, 30 plus 162 is 182.5. That's bigger than 180. It busts the 180 degrees when you add it to this. I like to use the logic of the length. And there's one last example. So, angle, 30 degrees. Again, I just kept the 30 there just for convenience. There's angle Q. Little q is 10. There's little q. R I put here so I can visualize the hinge. Is that possible to draw? Yep. Is it possible that the 10 could swing the other way? Maybe. So this could have 2 answers maybe. So as soon as I see this, I'm like, sine law, ambiguous. This could have 1 answer, it could have 2 answers. Ambiguous. Okay, so sine law again. Sine of 30 degrees over 10, there's my angle side pair, I'm finding angle R, equals sine of R over 24. No different than the other two, just different numbers. So I'm all excited, I go into my calculator, 24 times sine 30 divided by 10, so 24 times sine 30 divided by 10, I get 1.2 equals sine R. I know to find the angle, I always second sine it. So I get my calculator ready, second sine 1.2, and then I get an error. And then I think, did I do everything right? And looking back at my work, yeah, everything's right. As soon as I get an error, double check your work, nothing wrong. This tells us something. If you get an error out, or a domain error or a syntax error, that's the algebra telling you this can't even be drawn. And if you think about it for a minute, this length here, this length is actually too short. It's kind of like a little Tyrannosaurus Rex with little arms. It can't touch down. If you were to actually draw this with a protractor and make this 30 and this 24, 10 would not have enough length to get down to the bottom. And that's what this is telling us. But when we saw this, when I saw 10 there, I couldn't draw that to scale, so it looked possible. This tells me it's not. So this question has no solutions. That's actually my favorite case, because now I don't have to do any work about any from there on. But that's what's happening, is it's too short. All right, there's your 3 cases. No solutions where this side is too small. 1 solution where this side is longer than that side, so it can't swing the other direction. And then the fun one where there's 2 potential answers, because this length is smaller than that length, but long enough to touch down once here and long enough to swing over and touch down over there. And hence you get your 2 answers. Use the line rule with the 180 to find the second case R. So in the textbook for 2 answers, they'd have 2 answers for R. They'd have this and this, much like the quadratic formula. Either 1 answer, 2 answers, or none. All right, that is the sine law ambiguous case. Over and out. Talk to you soon.